Welcome to sureshbhattclasses. We are learning quantitative aptitude topic fraction. All the topic of quantitative aptitude are useful for many competitive exams like RRB, SSC CGL, Bank PO, Railways, and many government job exams and job interviews. These topics of quantitative aptitude are also useful for many entrance exams like GRE, SAT, ACT, CAT, GMAT, and many more. In this video, we are learning concept of fraction and questions based on fraction. The topic fraction. Number of the form P upon Q is a rational number where Q is not equal to 0 and P and Q are integers. Here P is called numerator and Q is called denominator, and P upon Q represents P parts out of Q number of equal parts is called fraction. Example of it, 3 upon 8 is 3 parts out of 8 equal parts. Here in the diagram, there are 8 parts, 1, 2, 3, 4, 5, 6, 7, 8. And the shaded region is 3 parts out of 8 parts. So this portion is 3 upon 8. And the remaining portion is 5 upon 8. The remaining blank boxes are 5 boxes, which is 5 upon 8. 5 boxes out of 8 boxes. So this is the basic understanding or definition of fraction. Now we will learn type of fractions. Types of fractions. Type 1, decimal fraction. A fraction whose denominator is multiple of 10 is decimal fraction. The given example is 0.3 is the decimal form is equal to 3 upon 10. 0.17 equal to 17 upon 100. 0.137 equal to 137 upon 1000. Here the denominators 10 or 100 or 1000 are multiple of 10. So these type of fractions 3 upon 10, 17 upon 100 or 137 upon 1000 are decimal fraction. Type 2, like and unlike fraction. Fractions whose denominators are same are like fractions and whose denominators are different are unlike fractions. And the example is 2 upon 7, 5 upon 7, 6 upon 7 are like fractions. Why these are like fractions? Because the denominators in all these 3 fractions is same, which is 7. In 2 upon 7, denominator is 7. In 5 upon 7, denominator is 7. And 6 upon 7, the denominator is 7. So these are like fractions. And 1 upon 8, 5 upon 6, 3 upon 4 are unlike fractions. These are unlike fractions because the denominator in 1 upon 8 is 8, in 5 upon 6 is 6, and in 3 upon 4 is 4. These 8, 6 and 4 are different. Therefore, these fractions 1 upon 8, 5 upon 6 and 3 upon 4 are unlike fractions. Comparing fractions. The following rules are helpful to compare 2 or more fractions. Rule 1. When 2 fractions have same denominator, then the fraction is greater whose numerator is greater. For example, 5 upon 7 is greater than 4 upon 7. Here the denominator is same. Both have denominator 7 and the numerator is 5 and 4. Here 5 is more than 4. Therefore, 5 upon 7 is greater than 4 upon 7 because both have the same denominator. So, the fraction is greater when numerator is greater if denominator is the same. Rule 2. When two fractions have same numerator, then the fraction is greater whose denominator is smaller. The example is 8 upon 9 is greater than 8 upon 11. Here the numerator is same. Both have the same numerator, which is 8. In 8 upon 9 and 8 upon 11, the numerator is 8, which is same. And denominators are 9 and 11. As 9 is smaller than 11, therefore 8 upon 9 is greater than 8 upon 11. We have to keep in the mind that when two fractions whose numerator is same, then that fraction will be greater whose denominator is smaller. Rule 3. When numerator and denominator are different in fractions, then make denominators same by taking LCM of denominators. We will learn it by one example. The example is compare 10 upon 11 and 11 upon 12. Here the numerators 10 and 11 are different and denominators 11 and 12 are different. So what we do? We take the LCM of 11 and 12. The LCM of 11 and 12 is 120. So we make denominators equal. What we do? We multiply 10 upon 11 by 12 upon 12 and we multiply 11 upon 12 by 11 upon 11. So what we will get? We will get 10 upon 11 multiplied by 12 upon 12 gives us 120 upon 132. 10 multiplied by 12 is 120 and 11 multiplied by 12 is 132. And 11 upon 12 multiplied by 11 upon 11 gives us 121 upon 132. 11 multiplied by 11 is 121 and 12 multiplied by 11 is 132. Now, in both the fractions, the denominator is equal, which is 132. Now we can easily compare the numerators. The numerator 120 is less than 121. Therefore, 120 upon 132 is less than 121 upon 132. That is 10 upon 11 is less than 11 upon 12. This way we can easily find which fraction is less and which fraction is more, or which fraction is smaller and which fraction is greater. Rule 4. To compare A upon B and C upon D. Then by cross multiplication, if AD is greater than BC, then A upon B is greater than C upon D. If AD is less than BC, then A upon B is less than C upon D. If AD equal to BC, then A upon B equal to C upon D. This we will learn by one example. 7 upon 8 and 6 upon 7. Here AD means 7 multiplied by 7, which is 49, and BC is 8 multiplied by 6, which is 48. Now as 49 is greater than 48 gives us 7 upon 8 is greater than 6 upon 7. The next is if AD is less than BC, then A upon B is less than C upon D. We take 3 upon 4 and 5 upon 6. Here AD is 3 times 6 is 18 and BC is 4 multiplied by 5 is 20. As 18 is less than 20, it means that 3 upon 4 is less than 5 upon 6. Now if AD equal to BC, then A upon B equal to C upon D. For that, 5 upon 7 and 15 upon 21. Here AD is 5 multiplied by 21, which is 105, and BC is 7 multiplied by 15, that is also 105. And as both are equal, it means that 5 upon 7 is equal to 15 upon 21. This way, when we have to compare two fractions, then we can use this rule. Rule 5. If denominator is less than or equal to 10, then directly divide the numerator by denominator and compare. For example, the given fractions are 7 upon 9, 6 upon 7, 5 upon 8 and 3 upon 5. Then by actually dividing we get 7 upon 9. If we divide 7 by 9, we put the decimal and we put 0 with 7, so it becomes 70. 70 when divided by 9. 7 times 9 is 63. So it will be 0.07. We are dividing up to one place of decimal, and if needed, then we will divide it for two places of decimal. Now we divide 6 by 7. As the fraction is 6 upon 7, we put decimal and put 0 with 6, so it becomes 60. 7 times 8 is 56, so it is 0.8. Now the next fraction is 5 upon 8. We put decimal and we divide 50 by 8. 8 times 6 is 48, so it is 0.6. And the next fraction is 3 upon 5. After putting decimal, we divide 30 by 5, so it also comes 0.6. Here it is 0.6 and it completely divides 3 by 5. So there are two numbers which has first place 0.6. So we divide further 5 upon 8. So when we divided 5 upon 8, we got 0.6 and 8 times 6 is 48. The remainder is 2. We carry one more 0, then the number becomes 20. 20 when divided by 8, it divides for 2 times. 8 times 2 is 16. So we divided it for 2 places of decimal. Now we have all the decimal equivalent of given fractions, and we see that the least number is 0.6, which is 3 upon 5. So we first write 3 upon 5, which is the least number. Then the next higher number is 0.62, which is 5 upon 8. So we write 5 upon 8, and the third number in ascending order is 0.7, which is 7 upon 9. So we write 7 upon 9, and the last is 0.8, which is 6 upon 7. So we write 6 upon 7, which gives us 3 upon 5 is less than 5 upon 8 is less than 7 upon 9 is less than 6 upon 7. This way we can compare the fractions by actually dividing it if the denominator is less than or equal to 10. We go to the next point. Rule 6. When numerator is less than denominator and difference between numerator and denominator is same, then fraction with smaller numerator is smaller. The given example is 5 upon 8, 4 upon 7, 7 upon 10, 8 upon 11. Here difference between numerator and denominator is same. So arranging fractions in ascending order of numerator, we get 4 upon 7 is less than 5 upon 8 is less than 7 upon 10 is less than 8 upon 11. I explain it again. The difference between 5 and 8 is 3. 4 and 7 is also 3. 7 and 10 is also 3. And 8 and 11 is also 3. So the difference between numerator and denominator in all the fractions is same. So as per the rule, the fraction with smaller numerator will be smaller. And if we observe in numerators, 4 is smallest, then next numerator is 5, then next higher numerator is 7, and then next higher numerator is 8. So we arrange these in the ascending order of numerators. So we get 4 upon 7, 5 upon 8, 7 upon 10 and 8 upon 11. And the smallest will be 4 upon 7. Then next greater fraction will be 5 upon 8. Then next greater fraction is 7 upon 10. And the greatest fraction out of these is 8 upon 11. Our topic is to insert any number of fractions between two fractions. Method 1. Insert a fraction between a upon b and c upon d, where a upon b is less than c upon d. Then insert a plus c upon b plus d. And we will learn it by one example. The example is insert a fraction between 1 upon 2 and 3 upon 4. So we have to add both the numerator, which is 1 plus 3 upon both the denominators, 2 plus 4. This is equal to 1 plus 3 is 4 upon 2 plus 4 is 6, and this is equal to 2 upon 3. So we are inserting 2 upon 3 in between 1 upon 2 and 3 upon 4. So I have written 1 upon 2. The next number will be 2 upon 3, which we have to insert, and the given number is 3 upon 4. So we have inserted 2 upon 3 in between 1 upon 2 and 3 upon 4. If we have to insert more numbers, then we use the same method and insert those numbers. So I will explain you. So if I have to insert two more numbers between 1 upon 2 and 3 upon 4, then I will insert one number in between 1 upon 2 and 2 upon 3. So I will add their numerators. The numerators are 1 plus 2 upon the denominators are 2 and 3. So we add 2 plus 3. This comes out to be 1 plus 2 is 3 upon 2 plus 3 is 5. And we have to insert one more number between 2 upon 3 and 3 upon 4. Sum of the numerator is 2 plus 3 and sum of the denominators is 3 plus 4. And this is equal to 2 plus 3 is 5 and 3 plus 4 is 7. So now after inserting the numbers, what we are going to get? Our initial number was 1 upon 2. Then the new number we are going to add is 3 upon 5. We had already inserted 2 upon 3. Now the new number we are going to insert is 5 upon 7. And we had already 3 upon 4. So this process we can continue to add more and more fractions between the given two fractions. I hope you have understood this method of inserting the fractions between two given fractions. We go to the next method. Method 2. If you want to insert n fractions between two fractions, step 1. Make the denominator same of both fraction equal to LCM of denominator by multiplying numerator and denominator by appropriate number. Step 2. Multiply numerator and denominator of each fraction by n plus 1. Step 3. Insert n numbers by adding 1 or 2 or 3 or n to smaller numerator with same denominator. We will understand it by one example. Insert 4 fractions between 1 upon 2 and 2 upon 3. The first step, step 1, to make denominator same of both fractions equal to LCM of denominator. First we will find the LCM of denominator. The denominators are 2 and 3 and LCM of 2 and 3 is 6. We have to make the denominator same of both the fractions equal to LCM, and LCM is 6. So we have to multiply 1 upon 2 by 3. So we multiply 3 to both numerator and denominator. So this becomes 3 upon 6 and 2 upon 3. So we have to multiply both numerator and denominator by 2. So 2 upon 3 becomes 4 upon 6. So we have completed step 1. We go to step 2. As we have to add 4 fractions between these two numbers, so n is 4 and n plus 1 is 5. So we multiply both numerator and denominator by 5. So this becomes 15. 5 times 3 is 15 upon 5 times 6 is 30 and other number is 4 upon 6. So we multiply 5 to both numerator and denominator. 4 times 5 is 20 and denominator is 6. So 6 multiplied by 5 is 30. Now we have the numbers 15 upon 30 and 20 upon 30. What is step 3? Insert n numbers by adding 1 or 2 or 3 up to n. N is 4 here. To smaller numerator with same denominator. So our first number is 15 upon 30. I am writing here, which is given to us. Now we will add 1 to 15. So it will become 16 upon 30. The next number is 16 upon 30. Now we will add one more to it. So this will become 17 upon 30. So we have added 2 numbers so far. We will add 1 to 17. It will become 18 upon 30. We will add 1 to 18. So it will become 19 upon 30. And we have inserted 4 numbers. And our given number was 20 upon 30. So this is 15 upon 30 is given to us, which is equal to 1 upon 2. And the number we have inserted are 16 upon 30, 17 upon 30, 18 upon 30, 19 upon 30, and the given number was 20 upon 30. So these are 4 numbers we have inserted in between 1 upon 2 and 2 upon 3. Now we go to the next example and we will insert more numbers to the same questions. Our next example is insert 9 fractions between 1 upon 2 and 2 upon 3. Earlier we had inserted 4 fractions in between the same 2 numbers. Step 1, we have to make the denominator same of both the fractions, which is equal to LCM of both the denominator. So denominators are 2 and 3 and LCM is 6. We already did in the previous example. So the number will become we have to make 1 upon 2 with denominator 6. So what we have to do? We have to multiply 1 upon 2 by 3 in numerator and 3 in denominator. So this becomes 3 upon 6, and 2 upon 3 becomes by multiplying 2 upon 2. So 2 times 2 is 4 and 2 times 3 is 6. Now we have both the denominator same. As we have to insert 9 fractions, so 9 plus 1 is 10. So we will multiply both numerator and denominator by 10. So this becomes 10 times 3 is 30 upon 10 times 6 is 60. And the number is 4 upon 6. 4 multiplied by 10 is 40 and 10 times 6 is 60. So the two numbers 1 upon 2 and 2 upon 3 have become 30 upon 60 and 40 upon 60. Now we will go on adding 1, 2, 3 to 30 and writing 60 in denominator of each number. So the inserted numbers will be, after 30 upon 60 is our first number, we add 1 to 30, so it becomes 31 upon 60. This is our first number. We add one more, so it will be 32 upon 60. Then we add one more, so this is 33 upon 60. We will continue adding 1 to each previous number. So 33 plus 1 is 34 upon 60, 35 upon 60, 36 upon 60, 37 upon 60, 38 upon 60, 39 upon 60, and our given number was 40 upon 60. So we have added 9 numbers, 31 upon 60 to 39 upon 60. These 9 numbers we have added in between 1 upon 2 and 2 upon 3. I hope you have understood the method of inserting the fraction between two given fractions. We go to the next point. To find fractional part of a number, the formula for it is fraction multiplied by given number equal to fractional part of number. And we will learn it by one example. The example is find 3 upon 4, 2 upon 3, 1 upon 2, 1 upon 4 and 1 upon 8 of 72. So we have to find the fractional part of 72 starting from 3 upon 4 to 1 upon 8. As per the formula, fraction multiplied by given number. The fraction is 3 upon 4 multiplied by given number is 72. And 3 upon 4 of 72, we divide 72 by 4. 4 divides 72 for 18 times and 18 times 3 is 54. So the fractional part of 72 is 54. That is 3 upon 4th of 72 is 54. Next we have to find 2/3 of 72. So 2 upon 3 multiplied by 72. 3 cancels 72 for 24 times and 24 times 2 is 48. That is 2/3 of 72 is 48. Now we have to find 1 upon 2 of 72. 1 upon 2 multiplied by 72. 2 cancels 72 for 36 times and 36 times 1 is 36. So half or 1 upon 2 of 72 is 36. Now we have to find 1 upon 4 of 72. So we multiply 1 upon 4 by 72. 4 cancels 72 for 18 times and 18 times 1 is 18. So 1/4 of 72 is 18. We have to find 1/8 of 72. So we multiply 1 upon 8 by 72. 8 cancels 72 for 9 times and 9 times 1 is 9. So 1/8 of 72 is 9. This way we can find the fractional part of a given number. From here, we derive a formula. So I am writing the formula which we derived from this example. From above, we derive important formula, and the formula is fractional part 1 upon its fraction equal to fractional part 2 upon its fraction equal to number. So this number is fixed. 3/4 of 72 was 54. 54, which is fractional part, upon its fraction. Fraction is 3/4. This is equal to 2/3 of 72 was 48. So 48 is fractional part upon 2/3. 36 is the fractional part and its fraction is 1/2, and these all equal to 72. 54 upon 3/4. 4 goes to numerator and 3 divides 54 for 18 times. 18 times 4 is 72. Similarly, 48 upon 2/3. 3 goes to numerator and 2 divides 48 for 24 times. 24 times 3 is 72. Similarly, 36 upon 1/2. 2 goes to numerator and 36 times 2 is 72. So this way we get the important formula, and in some questions without finding the number we can solve the questions of finding the fractional part. I am just explaining it, what type of questions it may be. 3/4 of a number is 54. Find 2/3 of that number. So without even finding 72, we can find 48. The given example is, if 5/12 of a number is 45, find 3/4 of that number. So using the formula which we derived, we can find the 3/4 of the number without even finding the number. 45 upon its fraction, which is 5/12. This is equal to, say x is that fraction, then x upon 3/4. This gives 45 multiplied by 12 upon 5 equal to x multiplied by 4/3. 5 cancels 45 for 9 times. 4 cancels 12 for 3 times. Therefore, x equal to 9 multiplied by 3 multiplied by 3 equal to 81. So without even finding the number, we have found out the 3/4 of that number, which is 81. I hope you have understood the concept and use of the formula. We go to the next point. Our next topic is type of fractions. The first type is independent fraction. When all fractions are independent of each other, we will learn it by one example. Example 1. A man travels 1/8 part of his journey by motorcycle, 1/4 part by car, 5/12 part by train, and balance 45 km by bus. Find total distance travelled by him. Here all fractions are independent, like 1/8, 1/4, 5/12. These all fractions are independent of each other. Our concept will be more clear when we learn about dependent fractions. So we go to the dependent fractions. Dependent fraction. The fractions other than first fraction depend on balance of previous fractions, are all dependent fractions. We will learn it by same example. Example 2. A man travels 1/8 part of his journey by motorcycle, 1/4 part of remaining travel by car, 5 upon 12 part of remaining by train, and remaining 98 kilometer by bus. Find total distance traveled by him. Here, except first fraction, all the fractions are dependent on balance of previous fractions. Now I compare these two questions. A man travels 1 upon 8 part of journey by motorcycle. In second question also, a man travels 1 upon 8 part of his journey by motorcycle. Now in first question, 1 upon 4 part by car. In second question, 1 upon 4 part of remaining travel by car. In first question, 1 upon 4 part is not dependent on the previous part, which is 1 upon 8. But in second question, 1 upon 4 part of remaining travel by car. Here remaining travel is important. That is, after traveling 1 upon 8 part, whatever is the remaining, he traveled 1 by 4 part of that remaining part by car. And in previous question or in first question, that 1 upon 4 part is not dependent on the 1 upon 8 part of his initial journey. Now next, in first question, 5 upon 12 part by train, and in second question, 5 upon 12 part of remaining by train. That is, after traveling 1 upon 4 part, whatever is remained, 5 upon 12 part of that portion by train. So these are the two questions with this similar data. In first question, all the fractions 1 upon 4 and 5 upon 12 are not dependent on the previous fractions. But in second questions, 1 upon 4 and 5 upon 12 are dependent on previous fractions. I hope you have understood the concept of independent fraction and dependent fractions. Now we will solve these both questions, and we will learn the formula used in both the questions, which are a little bit different with each other, and we will learn the concepts also. Balance travel equal to 1 is the total journey minus all those parts traveled by him independently. 1 upon 8 part by motorcycle plus 1 upon 4 by car plus 5 upon 12 by train, and the balance is 45 kilometer. So that is balance travel will come here, and this is equal to 45 kilometer is balance travel equal to 1 minus the LCM of 8, 4 and 12 is 24. 8 times 3 is 24, so we write 3, plus 4 times 6 is 24, so we write 6, plus 12 times 2 is 24, and 5 times 2 is 10. This is equal to 1 minus 3 plus 6 is 9 plus 10 is 19, is 19 upon 24, and that is 24 minus 19 upon 24 is 5 upon 24. Now total travel or total journey, balance of journey upon its fraction. This is equal to 45 upon 5 upon 24, and this gives 45 multiplied by 24 upon 5, and 5 cancels 45 for 9 times, and 9 times 24 is 216. So this is the total journey traveled by him with different modes, and the answer of this question is 216 kilometers. Please understand all the portion of the solution. The last formula is total equal to balance upon its fraction. This formula we have already derived. Now we will solve the same example with modifications for dependent fractions. So we go to that example. The second example is a man travels 1/8 part of his journey by motorcycle, 1/4 part of remaining, here remaining is important, travel by car, 5/12 part of remaining by train, and remaining 98 kilometers by bus. Find total distance traveled by him. Here, except the first fraction, all the fractions are dependent on balance of previous fraction. So please learn how I solve this question. Balance journey is 98 kilometers and its fractions are 1 minus 1/8, the first part traveled by him, and 1/4 of remaining. So I write it as 1 minus 1/4, and third fraction is 5/12 part of remaining. So I write again it as 1 minus 5/12. Here first part is independent and all other parts are dependent on previous fractions. So first part is 1 minus 1/8. Now 1/4 of remaining. So I write again it as 1 minus 1/4, and the third one is 5/12 of remaining. So I write it as 1 minus 5/12, and this is equal to 1 minus 1/8 is 7/8, multiplied by 1 minus 1/4 is 3/4, multiplied by 1 minus 5/12 is 7/12. 3 cancels, 12 for 4 times. Now total journey is balance journey upon its fraction. This is equal to balance journey traveled is 98 kilometers and its fractions are 7/8 multiplied by 1/4 multiplied by 7/4. We will bring all the denominator of denominator into numerator. So that comes out to be 98 multiplied by 8 multiplied by 4 multiplied by 4 upon 7 multiplied by 1 multiplied by 7. 7 times 7 is 49 and 49 divides 98 for 2 times. So total travel comes out to be 2 multiplied by 8 multiplied by 4 multiplied by 4. 8 times 2 is 16. 16 times 4 is 64, and 64 times 4 is 256. So the total journey traveled by him is 256. I hope you have understood solution of both the questions. The first was with independent fractions and second is with dependent fractions. We will solve one more example. The given example question is: a person spends 1/2 or half of his salary on food, 1/8 on education, 1/10 on rent, 1/5 on miscellaneous expenses. He still has $720. Find his salary. We have to find the balance fraction, which is equivalent to 720. So balance fraction equal to 1 minus 1/2, which he spent on food, plus 1/8, which is spent on education, plus 1/10, which is spent on rent, plus 1/5, which is spent on miscellaneous expenses. And this is equal to 1 minus LCM of 2, 8, 10 and 5, 40. 2 divides 40 for 20 times, and 20 multiplied by 1 is 20, plus 8 times 5 is 40. So 5 times 1 is 5, plus 10 divides 40 for 4 times. So 4 times 1 is 4, plus 5 divides 40 for 8 times, and 8 times 1 is 8. and this is equal to 1 minus 20 plus 5 is 25 plus 4 is 29 plus 8 is 37 upon 40 or equal to 1 minus 37 upon 40 is 3 upon 40. Now total salary equal to balance amount left with him upon its fraction, and that is equal to he had left $720 upon its fraction is 3 upon 40. 40 goes to numerator, so we write 720 multiplied by 40 divided by 3, and 3 divides 720 for 240 times, and 240 multiplied by 40 24 times 4 is 96, and we have 2 zeros with it, so it is 9600. I hope you have understood this example and its solution. Now we are going to solve many questions in upcoming videos on fraction. Here completes this video. Please like, share and subscribe to this channel, and don't forget to press the bell icon to get the latest notifications. Thanks for watching.